All right, we're going to start another video here where we look at set and drift chart plotting problems that you're likely to see on your U.S. Coast Guard license exams. This is going to show you how to increase your confidence by solving them using a radar plotting sheet. It's another useful tool in your exam taking toolbox. Why radar plotting sheets? Well, for one, you get a smaller and adjustable scale. You have scale options to work with. This helps you avoid trying to work with a thin sliver of a triangle on your chart, and it reduces the number of overall moves. That's your line transfers and your measurement transfers that you need to make. We're going to check out a real problem from the actual charting exam. We're going to look at chart 12221, the Chesapeake Bay entrance. And the section we're going to be working with is going to be highlighted in this box here. From your 815 position, you want to make good course 263 true. Your engines are turning RPM for 12 knots. The current is 050 true at 1.9 knots. Adjusting your course for set and drift, at what time should you expect to enter the red sector of Cape Henry Light? First off, we have our magic word set and drift. That lets us know that we're working with a set and drift problem. We're looking at Cape Henry Light, which is here. And Cape Henry Light is a sector light. So we're interested in what time we're going to see the red sector of the light. So I'm going to highlight that on our chart. Our chart's a little busy in that area. I'm just going to draw in the red sector here. In order to know when we get there, we have to know where we're starting from. So we're going to put down our 815 position. We have latitude 37 degrees, 1 minute north, and we're going to put in our longitude. That's 75 degrees, 42.7 west. That's going to give us our 1815 fix, and we'll label that accordingly. To further indicate that we're dealing with a set and drift problem, we have the magic words make good. We want to make good course 263. That's our track line, and our track line is the path that our ship is going to follow through the water. Our actual heading, the ordered course that we're going to give our helm, is going to be different. We're going to go down to our compass rose and get our 263 course line and lay that down as our track. Make sure we got that lined up, and we're going to slide that up to our starting position, our 1815 fix. And we're going to extend our track line out, making sure that it intersects our red sector, because we're going to need to measure that distance in the future. Can't figure out time without distance. So we have our 263 track line down. Now, to go along with the distance, we really need to figure out the speed that we're traveling along that track line. It's easy to look at the problem and see, oh, we're turning for 12 knots. That means our speed is 12. No, it's not. Just like the track line itself is our course made good, our speed is going to be a component of our actual engine speed plus the effect of the set and drift. And we're going to call that our speed over ground. That's our speed relative to the surface of the earth. And we don't know it yet. We got to figure it out using a set and drift vector triangle. Now, you can put that triangle right on your chart. You can take your 050 at 1.9 knots for your set and drift. You could plot it out. You could do a bunch of transfers, and then you'd be squeezing your dividers together to try to measure some tiny little distance on your chart here. That's fine. That's not a wrong approach. We're going to look at how to do this on a radar plotting sheet because this is an exam. We want to keep things clear, clean on our chart, and hopefully improve our accuracy so we get the right answer on this question. Jumping over to our radar plotting sheet, we're going to start with what we already know. We're going to plot out 263, that's our track line. Find that and put it onto our maneuvering board. Once we have our track line, we're going to add our set of 050. Find that on our ring and draw that in. We're now ready to plot our speeds, but as you can see up near the top of our sheet, the range rings stop out at 10. That's our outer limit. That means we're going to go up to the next largest scale, which is 2 to 1. And we have a scale available to us on the left-hand side. We can also do this mathematically. We just have to normalize both of our numbers using the same ratio. So if we take our 12 knot speed, we divide by 2, get it half that, and we get 6 knots. We can then take 1.9, do the same thing, and we get 0.95 knots. If you're comfortable doing the calculations like this, great. You can plot them right out on the sheet, no problem. I'm going to show you how to use the vertical scale on the left-hand side, the 2-to-1 scale. This is in the interest of understanding the technique, and it lets you bypass any kind of math calculations. To use our scale, we're going to put our unmodified speeds down. We have our 12 knots for our engine speed. That's about here. And we're going to find our drift, which is 1.9 about here. We're going to grab our drift speed with dividers, since it's the only complete vector pair that we have right now. That's a speed and direction. And we're going to transfer it to our set line. This is going to become the anchor point, the basis for measuring out the other vectors. Once we have our drift of 1.9, we're going to go back to our scale and we're going to measure out 12 knots of engine speed. And we're going to carry that back to our drift mark. Once we have our anchor, we're going to make a tick, our intersect for our 263 track line. All we got to do now to complete the vector triangle is connect up our 2 tick marks. And we're going to want to immediately transfer this line back to our center point so we can get a direction. That's going to be our adjusted course. And it looks to be right around 258. So 258 is the heading that will compensate for our set and drift and keep us on our track line of 263. We got to keep in mind the context of our question though. 258 is useful and it's going to be a solution in a lot of other problems. However, the problem we're looking at is based on the time, distance, and speed associated with the track line. So we got to find the final vector pair, find the speed for our 263 track. That's the speed over ground. Fortunately, all we got to do is take our dividers and measure out the red leg of our triangle here. Let me take that back to our scale. And it looks like about 10.5. So our speed over ground is going to be 10.5 knots. And we can plug this back into our relatively uncluttered chart. Isn't that nice? A lot of open space to work with. So we have our time and distance formula. Time is going to equal the distance divided by our speed over ground, SOG, which we now have a value for. It's 10.5. We have one last variable remaining, d, distance. And so we're going to use the scale on the chart here. And we're going to measure out the distance we cover between the 815 fix and the red sector of Cape Henry Light. Our chart scale is limited, so I'm going to take 5 nautical miles, put that down, and then figure out the remainder and add the 2 segments together. So I have 5 nautical miles, and it looks like the remainder is going to be between 3 and 4. It's going to be 3.55. Perfect. So 3.55 plus 5 nautical miles lets us finish out our formula. So time is going to equal 8.55 nautical miles divided by our speed of 10.5 knots. We're going to get 0.8142. And remember that's hours, so we have to multiply by 60 to get t in minutes, time in minutes. 0.8142 times 60, we get 48.8. I'm going to round that up to 49 minutes even. 49 minutes of elapsed time. 1815 fix, we add 49 minutes to that, and we get 1904 for our time. And look at that, it's a perfect answer, answer B. It's always nice when the answer comes out nice and even right on the nose. So that's how you solve a set and drift charting problem using a radar plotting sheet. Thanks for checking us out at Oceans Unlimited. If you found this video helpful, please consider leaving a like or throwing a comment down below to help us grow the channel. Also, be sure to subscribe if you have license exams coming up, or if you're just looking for some tips and tricks. See you next time.